So we're standing here on Earth, right? We're going to throw a ball. We throw the ball, it's going to fall down, right? Gravity's going to pull it down. What's going to be the shape of the ball? Its path? Okay, like a parabola, right? It's just going to fall down like this. Okay? What if we were to throw the ball harder? How would that change the shape? Okay, it would go farther, right? So if we threw it harder, the ball would go farther and it would make like a longer distance parabola. What if we threw it faster still? What would happen? Okay, yeah, it would just keep going farther, right? Well, notice as we keep increasing the speed, this distance keeps increasing, but the Earth itself is also curved, right? So it's conceivable. What if we threw it fast enough so that as it fell, it kind of fell at the same rate that the Earth was curving? Well, what would happen to our ball? Okay, it would never hit the ground, right? It's falling towards the Earth, but the Earth is curved, so it falls and curves at the same time. So it actually would never actually ever hit the ground, right? In fact, after a while, if I turned around, what could I do? Catch the ball, right? It would go all the way, assuming it doesn't hit mountains or anything like that, right? If we threw it, we would go all the way around and I could catch it, or I could duck. What would happen if I duck? Then it would just keep going. And if I duck again, and keep going and going and going, right? So what's this called? This is called an orbit. So obviously we can't do this, but we can put things in orbit. We could put a satellite in orbit, right? And if we do the same thing, so what happens with the satellite is we give it some speed, and the satellite keeps falling and falling and falling, but it never actually hits the surface. It just keeps going around and around and around. And that's an orbit. Okay? In fact, when you see astronauts like in a space station, what does it look like they're doing? When you see astronauts in space station, what are they doing in there? Looks like they're, floating around. Looks like they're floating. And if you were to ask, say, someone on the street, or perhaps if I were to ask most of you, what would you say? Why are astronauts floating when they're out in outer space? Okay? So many people would say because there's no gravity. And if you were just to go ask all your friends, they would probably all say because there's no gravity in outer space. But is that true? Okay? It's not true, because why is this going in orbit in the first place? Because of gravity, right? It's continually falling to the ground. So you might think there's no gravity in outer space, but there is. There definitely is. Gravity is actually the force that keeps us in a circle. If there was no gravity, if all of a sudden Earth's gravity disappeared, what would happen to our satellite? It would just keep going. Yeah, forever and ever. In fact, if I just threw my tennis ball and there was no gravity, if I just threw it like up, what would it do? It would just keep going, right, forever. So there's definitely gravity in outer space. We also know because... Oh. Didn't you have them with that? Oh, yeah. Okay, I'll print them for you in a few minutes. So there's definitely gravity here. Think of the moon, for example. Does the moon go around the Earth, right? Why does the moon go around the Earth? Because it's gravity between the Earth and the moon. Why does the Earth go around the sun? Because of gravity between the sun and the moon and the Earth, right? So there's definitely gravity in space. All right, so anyway, this is the whole concept of the orbit. Let's go ahead and do an example problem here.